Hello students, in your packet we have discussed this particular question and we have done question A, 1A and 1B together. So here we are going to try and work out question C. So the first thing you need to do is to draw the inverse of each relation, so fx and its inverse. So let's see, what do you know about the graphs of a function and its inverse? We already learned that they are just mirror image of each other along the line y equals x. So to draw this inverse graph, inverse function graph, we are going to look at first how to sketch function f itself. And as we know, when we have no clue how it's going to look like, what you could do is just choose some values of x, as many as you can, and try to figure out their images. So who is the partner according to the rule of function f. And from there you have some pairs of coordinates, and those coordinates you can plot and connect in your graph. So let's try. If I take the value of -2 for x and I substitute it here, then -2 cubed. So I'm just going to give and write one example. The rest we can just work it out in our head. Say if x is -2, it means I will have -2 cubed and then subtract 1. -2 cubed is -2 times itself 3 times. So then -2 times -2 times -2, you will have -8 minus 1, so -9. So I'm going to put here -9. That's the image of -2 according to function f. If x is -1, -1 cubed is -1 and minus 1, so we will have -2. 0 cubed is 0, subtract 1, that's -1. 1 cubed is 1, subtract 1, that's 0. 2 cubed is 8, so 2 times 2 times 2, and then subtract 1 will give you 7 as its image. So from here you see that you will have -2, -9 in your graph of function f, -1, -2, 0, -1, 1, 0, and 2, 7. So let's try and plot them. -2, let's just do 1 unit per box like this. So then -2 and -9. See if I counted correctly, I think so. So then -2, -9 will be somewhere here. -1, -2 will be somewhere there. 0, -1 here. 1, 0 over there, and 2, 7. Let's see, I think it's somewhere here. So let's see, you check if it is correct. So, all right, so let's try and connect them then. Hopefully I can make this pretty, but in your packet you should try and do it better. So, okay, something like this more or less. So, as we established before, when we are looking for the inverse of function f, basically it's you just swap positions between x and y, right? It's some kind of like flipped over. So then in this case, without even knowing the formula for the inverse function, I already can establish that in the graph of inverse of f, I should have -9, -2 as a point, right? It's just flipped over. We just swap the position of x and y. So I should also have -2, -1, -1, 0, 0, 1, and 7, 2. So let's see, how does it look like? So I should maybe use a different color here because red is already taken for the color of its mirror. So let's use green. negative 9 comma negative 2. So more or less I will have a point over there, negative 9 comma negative 2. Negative 2 comma negative 1 here, negative 1 comma 0 over there, 0 comma 1, and 7 comma 2. So then it's somewhere here. Again, one more time, you should check if this is in the right position. I think so. So I will try and connect those points. More or less you will have something like this. Oops. Okay, well, you try to make it prettier on your packet, okay? So we see here clearly along the line y equals x, the graph of fx and the graph of inverse f, they are actually mirror image of each other along the line of y equals x. And remember, there will be somewhere where they actually cross here. That's where the y coordinates is equal to x coordinates. So here it means the mirror is just located on, the point or the image is just located on the line itself. Right, so we'll talk about that a bit more later on. Right now, let's try and work out the next problem, which says that you need to find the equation of the inverse and to state whether the inverse is a function or not. Well, the third one we can answer easily already. Let's look at the green graph, and if you do the vertical line test, every time you make a vertical line, then you cross the graph only once. So of course then f inverse x in this case is also a function. So the only thing we have to do now is try and find the equation of the inverse function. So let's try and work it out. I can write that function in a different way. We call usually the image of x as y. So I'm going to write function f formula or equation in the form of y equals x cubed minus 1. Right, so do you remember what you need to do first when you are trying to find the formula of the inverse of a function? So basically, basic principle, you swap the position of y and x. So that's the first thing that we need to do. If I swap the position of y and x, then I will have x equals y cubed minus 1. And afterwards, the only thing I have to do is to try and make y the subject. So let's see, what can we do? We have subtraction by 1 here, so we can do add 1. So plus 1 both sides. If we do so, then we will have y cubed on the right hand side and x plus 1 on the left hand side. So how do we cancel out this operation y cubed? So of course the other way around process, we can take the cube root of x plus 1. So then in this case, if you do so, then on the left hand side you will have the cube root of x plus 1, and then cube root of y cubed is just cancelling out, so then you will have just y on the right hand side, and here y is already the subject of our equation, so you are done. The only thing you have to do is just write it down properly now. The formula of the inverse of function function f is the cube root of x plus 1. So try it out and work on several exercises, and hopefully everything is okay. Good luck.